Welcome to Intro to STEAM. I'm Miss Pena. I'm excited to have to be teaching again this year. This is my 4th year teaching. Prior to teaching at Cathedral, I was an engineering consultant. My background is in mechanical engineering. I was an engineering consultant for about 20 years. And so I'm going to give you a little background on myself first. Most of my career was doing engineering consulting where I did product design and structural analysis. Here's one of my projects where I designed the camera housing that protected the video camera used in the filming of the Pirates of the Caribbean. So I designed this in 3D modeling in SolidWorks and then had it made by machine shops. I also performed the structural analysis in it to make sure that it could withstand the pressure from the water. I also helped develop and start the company Seabotics, which makes remote ocean vehicles. And here's an example of like a detailed drawing. This is pretty sophisticated, but I'll be teaching the students this year the basics of creating of making a 3D model and making a detailed drawing. So for our class, the class is divided into, the grading portion is divided into 4 categories. Participation is 20%. That's trying to prompt the students to engage and participate in the class even in the remote environment, because it's a really challenge to get the students to speak up when they're logging in remotely. 15% is check-ins and quizzes. That's basically basic mini quizzes to just make sure that the students are paying attention and understanding the material. 15% is homework or class assignments, but the majority of the graded comes from projects. So the students will be doing a lot of projects. Most of them are going to be group projects. Each project has a group component where the group makes something together, and that's a group grade for that component. But the majority of the grade on the projects is based off of their engineering design notebook, which is individual. So even though they're group projects, their grades are primarily individual grades. The required course material, hopefully all of the students has purchased an engineering design notebook. This is the main thing. They're going to be doing all of their designs and brainstorming and research in their engineering design notebook. Other things that would be useful is a ruler. Once we go back to campus, they're going to need personal safety glasses because we're going to be learning how to use power tools, and it's important that they wear their safety glasses when they're using the power tools. However, they do not need that until we go back to campus. Closed-toed shoes are required when they're using power tools. Other things that when they're making projects, whether we're remote or in class, they may need to purchase some things that will supplement their project. Often they can get most or all of their supplies from school, and there might be times when we send a kit home from school if we are still in remote learning. But they may want to or need to purchase a few things additional for their projects. The class objectives. So the main objective for the Intro to STEAM class is to introduce them to a lot of basics in the engineering world. We start off teaching them the engineering design process. We go through brainstorming and the best ways of brainstorming. We talk about research and how that's important in developing different engineering things. Then we go into design, what's needed for design. We teach them computer-aided design using Onshape, and teach them a little bit of things about drawing things to scale, how to make a detailed drawing, and things like that. We then teach them about prototyping and testing. They also learn about electric circuits and computer programming. So this is a tentative schedule based on the different circumstances this year. Things are being a little bit slightly adjusted from what we've done in the past, but the main components are going to be the same. So here are some examples of the projects. So our first big project this year is going to be the Popsicle Bridge project. And so here, these 2 students made this popsicle bridge, and it held I think it held like 200 or 300 pounds. It was very strong. We have some bridges I had one bridge that held like 1 pound, but this one was a really strong one. It held a lot. They were very proud. So not only do they research the best construction and then try to make the best construction, and then we test it, but then when it's done, they're supposed to look at, hey, where did it fail? Why did it fail? They're supposed to analyze what could they have done differently to improve that project. This is, I believe, a box when they're making their boxes. and using the power tools. You can see the power tools in the background, and he's got his safety glasses on there. Safety first. Here is the Newton's car project. So this is a mousetrap car, but different students do different things. And so this is a project where we introduce the testing, where they can test, because they have to hit 3 different distances consistently. And so they have to do a lot of testing to make those marks. And here is architectural model and circuits, where they make a model of a house, and then they light up the house using circuits and Christmas lights. So those are just some samples of projects that we've done in the past. I'm looking forward to an exciting year. And if you have any questions, please email me, spena@cathedralcatholic.org. And hopefully we can be back in class sooner rather than later. Have a great night.